Alright, we're going to look at respiratory system now. So breathing. Functions of the respiratory system is to intake oxygen and to remove carbon dioxide. Those are the main respiratory functions. Breathing action, so inspiration or breathing inwards. The diaphragm at the bottom of the rib cage contracts and flattens. At the same time, the intercostal muscles, which are in between the ribs, contract, and that lifts the rib cage up and down. So if you breathe in now, you'll feel that action taking place, and if you breathe out, you'll feel the reverse happening. And the end result of that is that you get air into the lungs. Expiration or breathing out is when the diaphragm relaxes and goes up. So, like as I just said, if you breathe out, you'll feel that happening. The intercostals relax and the ribs go down. And the end result of that is air out of the lungs. So a little diagram there of breathing action in and out. We have a respiratory system anatomy here, so quite simple really. This is the passage of air into the body. So it goes into the mouth, past the pharynx at the very back of the throat, through the larynx or the voice box, into the trachea, this sort of tubed area. It has these cartilaginous tubes in it to keep it open so that you don't get a collapse of the breathing tube. Into the bronchi, which are the two big tubes coming off the trachea. And then we have bronchioles, they're like little branches that make up the lungs. So you can see there where the bronchus on the second arrow down comes in from the trachea, and then the bronchioles, these little branches of, well, sort of branch-like substance which carries the air mix deep into the lungs. You may be surprised at the composition of air that we breathe in and breathe out. It's quite interesting that nitrogen, for instance, we breathe 79% in and breathe exactly the same amount out. So there's only actually 21% of air or oxygen that we use. So 21% of oxygen is inhaled, and 17% of the oxygen we breathe in is actually breathed out, and only 4% of carbon dioxide. So quite surprising numbers. We have terminology that we use in the respiratory system. We have something called tidal volume, which is the amount of air that we inhale and exhale in one normal breath. We have vital capacity, which is the maximum amount of air inhaled and exhaled in one breath, just in a big breath. And then we have residual volume, so that's the amount of air or reserved capacity in the lungs after we breathed out, so what's left, in other words. So all of that is measured in millilitres. We're going to look at alveoli and gas exchange now. So this is actually where oxygen enters the body and enters more specifically the blood. The alveoli are little air sacs that are located at the end of the bronchioles, and they're the site of where this gaseous exchange or diffusion takes place. Diffusion is the movement of gas from an area of high concentration to an area of low concentration. So, as the oxygen comes into the body, it diffuses into the blood through the alveoli. The oxygen is then transported around the body in the blood via the capillaries and larger vessels. And finally, carbon dioxide is a waste product of cellular respiration. So, carbon dioxide is breathed out. So we now have a little look at this slide, which actually features an alveoli. So you see the bronchiole coming in on the top arrow, the alveoli there, where we have the blood coming in from the pulmonary artery on the left, coming into the alveoli, carrying this CO2 rich blood that then diffuses through the alveoli and oxygen-rich blood, oxygen coming in through the breathing tract into the alveoli and then taken away in the pulmonary vein, red oxygenated blood to the right. And then the reverse of this, so this is the CO2 now being breathed out. So it's a fairly complicated method, but it's quite simple to understand if you look at these diagrams.